Our next speaker is Amanda Millin. Amanda spent a decade as a journalist, mainly covering fine dining and luxury travel, until an interview with a sustainably minded, Michelin-starred chef landed her on a community-based sea cucumber farm in Madagascar. She immediately knew she wasn't returning to her previous life. The newfound quest to work on the ground with coastal communities led her to a traditional Hawaiian fish pond on Oahu, and eventually to Scripps, where her desire to learn hands-on boating skills inspired the school's first boat mechanics class. The title of Amanda's presentation today is Indigenous Aquaculture, a tool to support food security.
Thank you, Samantha. I spent the first month of quarantine on the phone with coastal communities in the Pacific Northwest and Hawaii. Repeatedly, I heard hope. Perhaps this is the moment where the rest of the world starts to value small-scale food production. And perhaps it is. COVID-19 has disrupted food supply chains. As a result, there has been an uptick in local produce boxes, otherwise known as CSA boxes or community-supported agriculture. Now, those even have a new sibling, CSF boxes, or community-supported fisheries. And the one paper that I could find that's been published to date so far on this topic attributes this uptick to, and I quote, a shaken confidence in the security and reliability of the current centralized food system. For most of us in the developed world, this is probably the first time we've felt this way. But for vulnerable island nations and coastal communities, this is not a new feeling, especially with climate change. Indigenous aquaculture can be part of the solution for them. This technology is not well known outside of the communities that it currently exists in, and it doesn't even really have an official name. I used indigenous aquaculture to be consistent with several movements that are happening on the ground right now, including an IUCN motion that is calling for a global database of indigenous aquaculture knowledge. But they're also called mariculture, traditional food systems, social ecological systems, low tech. What all these names have in common is a system that can enhance the natural production of seafood while conserving the ecosystem and resources that it's a part of. I chose to focus on two of these systems, Hawaiian local i'a and clam gardens in the Pacific Northwest. And I wrote what I hope will be a peer-reviewed paper about how both of these systems can function in climate change. Because as great as they sound on paper, there is a question of whether or not the traditional ecological knowledge or the tech that they're founded on will be able to continue functioning in the same way in light of anthropogenic climate change. Now, it's not surprising to hear that there's not a large breadth of scientific literature that looks directly at climate change through an indigenous aquaculture lens. But I went in search of the next best thing, proxies. Climate change research that already exists that can help shine some light on how these systems may function in the future. And in doing so, I was able to support the idea that not only will these, or can these systems continue to function, they can help coastal communities adapt to and mitigate climate change. We are just going to focus on functionality today. But before we get there, it's important to clarify that indigenous aquaculture is not a solution for feeding the planet. They do not rely on feeds or external inputs of any kind, and therefore they cannot scale up. But they can help local small-scale communities become more food secure, and in doing so, they can alleviate pressure from larger global food systems and help make those systems more sustainable. So let's start with clam gardens. A clam garden is essentially a natural beach in Alaska, British Columbia, and Washington State. They have the presence of a simple man-made rock wall. These rock walls have been radiocarbon dated, to 3,500 years old, and their simple presence allows them to produce 4 times as many clams as beaches in the surrounding area. And they did so for 6 local species of clams, but predominantly Pacific littlenecks and butters. In Kwakwala, which is a language that is spoken just north of Vancouver Island, clam gardens are called lohiwe, which has two very important meanings: roll together and low tide mark. And that's because communities would gather together on the beach and they would roll essentially basketball-sized boulders down, always to the lowest low tide mark, areas that are usually underwater. And that is where they would build their wall. Now, over time, the sediment would accumulate on the beach side of the wall, and it would flatten out the slope of the beach, essentially creating a terrace. As the tides come in and out, this terrace retains more water, and it submerges the clams in their ideal nutrient-rich habitat. Then, as community members come to harvest the larger clams, they actually return empty clamshells to the beach, which changes the sediment from a fine silt that smothers larval or baby clams to a large grain shell hash. This shell hash is rich in calcium carbonate, which is important because the Pacific Northwest is experiencing ocean acidification more intensely than the rest of the globe. As the ocean becomes more acidic, it becomes corrosive, and it makes it hard for the larval clams to pull the calcium carbonate that they need from the water to form their hard shells. This graph is from a paper that is in prep for publication. Blue boxes are non-walled beaches, green boxes are clam gardens. And what scientists are seeing with these long, large green boxes is that the sediment of clam gardens consistently has much more calcium carbonate than surrounding beaches, which suggests that a larval clam may have a better chance of surviving ocean acidification within a clam garden than outside of one. Plus, there is exciting new research that suggests clams may not even need to pull calcium carbonate from the ocean in the future. In this study, adult clams were exposed to highly acidic waters, 7.7 pH to be specific, and their offspring were actually able to internally make the calcium carbonate that they need, and it required less metabolic energy than pulling it from the ocean. Clams in clam gardens may be able to adapt similarly. Now moving across the ocean, the Pacific, to Hawaii. Loco means pond, and ia means fish. And these fish ponds are essentially a natural estuary that has been enclosed and enlarged by a man-made rock wall. They targeted local herbivorous fish, and they were built throughout the watersheds of Hawaii. These watersheds were managed using an innovative system called an ahupua'a, which ran Mauka to Makai, or in English, mountain to sea, all the way out to the coral reefs. And mid-mountain, they would build a specific type of local ia called a local ia kalo. Kalo means taro, and these local ia kalo would cultivate fish and taro together simultaneously. Fresh water flows down the mountain into the local ia kalo, where it is cleaned, and the fish and the taro add nutrients. This rich water then flows downstream into coastal local ia, which are attached to the ocean. Their rich brackish water mix then is abundant in phytoplankton, so much so that fish would naturally recruit themselves swimming into the pond to eat it. Now, because these coastal local ia are brackish estuaries, climate change threatens to alter the amount of fresh and salt water going into them and potentially make it an uninhabitable environment for fish. Scientists are still trying to better understand hydrology and estuaries in general. It's a complex web of rain patterns, wind patterns, sea surface temperatures, sea level rise. But there is still good reason to believe that local ia and estuaries in general will be able to adapt. Local ia and estuaries are naturally highly dynamic systems, which have a long history of adapting to extreme changes. In the case of local ia, they've been doing so for about 800 years. Plus, there is new research coming out that these type of hydrologic changes will come on slowly over years, allowing local EA and estuaries time to adapt. But there is the threat of fast onset changes, like more frequent tsunamis and hurricanes. But local EA in general, their design is meant to address this. Indigenous aquaculture in general was built for prevailing conditions of the time. That's different than today. We build with a permanence mindset. Think plastic. We want it to survive the test of time. But these systems that have survived for centuries were built with an impermanent mindset. Local EA and clam gardens dry stacked their walls without the use of concrete, which meant they were consistently falling down and needing to be rebuilt. Local EA also utilize gates called makaha that are made out of wood. And I actually worked on a local EA on the North Shore of Oahu before coming to Scripps. And we tried switching out these wooden makaha for a more permanent metal one. And we quickly found that they were less cost effective and more labor intensive. So if we stick to the traditional ways of building local EA, we will actually be able to move them inland or build the walls higher if and when necessary. There are already communities that are starting to restore local EA and clam gardens. And they are partnering with a growing international group that is working to document other systems like these around the world. Funding to date has largely been related to cultural heritage and education. But these systems can be more than living museums. If we invest in them as an innovative tool, which is what they were designed to be, then coastal communities can be more food secure. In the process, they can preserve centuries of rich culture, languages, songs, traditions. With that comes deep ecological knowledge. From a climate change standpoint, that ecological knowledge is local expertise into the front lines of climate change. It's also a robust baseline data set that we could lose if we don't study it soon. Plus, there are lessons about how to better govern sustainable land management systems and examples of how we can include eco-designs into our own modern architecture. We do not need to revert to traditionalism in order to start incorporating this knowledge, but we do need to change our perception of small-scale local solutions if we want a more balanced future. Thank you. And there's so many people to thank for this project. I won't have time, but first and foremost are the communities and the elders who have accepted me and been willing to share their knowledge with me. And then my wonderful Capstone committee who helped me work through all of this knowledge and digest it in a way that hopefully is meaningful. Plus my cohort, Samantha and Risa, to my family who put up with me for the last 10 months, or 10 months, it felt like 10 months, 10 weeks. During COVID, I am so grateful. And I will take any questions.
Thank you, Amanda. So are you suggesting that we build new loco-ia and clam gardens around the world?
Thank you, Samantha. That's a great question and one that I am often asked. Anthropologists and archaeologists believe that most cultures around the world had a way of enhancing seafood production like this that is culturally relevant and that is geographically relevant. So instead of building loco-ia and clam gardens elsewhere around the world, it would be a good idea to identify what those systems are if that knowledge has been lost, and to restore that instead.
Great. And we have a question from the web. They say, I heard Amanda refer to CFAs and the IUCN's Indigenous Aquaculture Database Initiative. Did Amanda identify other policy initiatives supporting Indigenous aquaculture?
I did not, which is an astute observation. There are not other policy movements to my knowledge. It's mostly right now there's a NOAA grant that began this year that is 3 years between Washington Sea Grant and Hawaii Sea Grant, and is working with KUA, a nonprofit that I worked with that shared my project, and the Clam Garden Network, and they are starting to document these systems and work toward this Indigenous global knowledge bank, separate from IUCN, but kind of simultaneously. But that is the only real policy IUCN so far. There will be more.
Great. And we have a question from the web from Neha in San Diego. What kind of challenges would occur when trying to transfer these methods to different locations?
The traditional ecological knowledge that these systems are founded on are hyper-local in nature. It requires a really deep understanding of how the ecology in that specific location works. So it would be very challenging to transfer it to a different location because the ecological processes may not be the same, the species may not be the same, climate, etc. But there are overarching ideas, as in maintaining a whole watershed, minimal human inputs, etc., that can be transferred very easily. Thank you.